So this is 4-2 solving systems of equations by substitution. In this lesson, we'll be able to solve a system of equations using the substitution method. Okay, so last lesson we learned how to solve the system of equation by graphing, and there were one solution and infinitely many solutions and no solutions. Today, we're going to look at the same thing, but with different method by substitution. We're going to focus more on the algebra part. Let's look at model and discuss. Rochelle is conducting an experiment on cells on Elodia, a kind of water plant. To induce plasmolysis at the correct rate, she needs to use an 8% saline solution. But she has only the solution shown on hand. Solution A is 10% saline. Solution B is 5% saline. So if Rochelle mixes the two solutions to get 1,000 milliliters of an 8% saline solution, which will she use more of? Okay, so first of all, what method can you use to write equations for this situation? You can draw a diagram to represent how the separate saline solutions are combined, and then represent the steps of combining the saline solutions as an equation. So this is 10% saline, but the first one has both of them are 1,000 milliliters, right? If you have 10,000 milliliters that has 10% saline, how many millimeters is it saline? 10% of 1,000 of this is 100 milliliters. So 100 milliliters saline for that. But solution B, if you have the same 1,000 milliliters, that's 5% saline. 5% saline should be, if 10% is 100, 5% should be half of that, which is 50 milliliters. Okay, so 50 milliliters out of 1,000 milliliters would be 5% saline. So if she got two solutions, if she mixed it to get 1,000, the same milliliters of 8% saline solution, which will she use more of? If she used half and half, 500 milliliters, 500 milliliters from half and half, it's going to average to exactly half from 5% and 10%, 7.5, right? But if you uses more of the 10%, she'll get closer to 10. If she uses more of 5% solution, she'll get closer to 5. Is 8% closer to 10 or closer to 5? It's slightly closer to 10, right? So you can say she will use more of the 10% solution, because explain 8 is closer to 10 than 5. Okay. Part B, how can Rochelle determine the amount of each solution she needs to make the 8% saline solution? Okay, she can set up a system of equations modeling her problem. She knows that the sum of the amount of 10% saline and the amount of 5% saline must be 1,000 millimeters. So we can set them equal to X and Y. And they could be modeled by the equation X plus Y is equal to sum of 1,000 millimeters. But the amount of each solution times its concentration is a different thing. So you can multiply. How did you get 100 milliliters and 50 milliliters? By multiplying the decimal of the percentage to your total milliliters, right? So you can write another equation saying 0.1x plus 0.05y is equal to 80 millimeters, right? Because if you end up with 8% of this is 80 millimeters. Okay. So why don't we write that down? Okay, part C. Are there any methods for solving this problem other than the one you use in part B? We learned how to graph it, right? Graph the equations, or you can manipulate both equations so they're set equal to y. And then you set the two equations equal to each other and then solve. So instead of having two equations in the beginning, you can already be having one equation that has two different sides. Okay, and then you can solve it. Because 1,000 minus x could be 1,600 minus 2x. Okay, because if you multiply the second equation out and simplify, you can have y is equal to 16,000 minus 2x, 1,600, sorry, 1,600 minus 2x. So that you set them equal to each other. If you change those to solve it as that form. Okay. And this gives a more precise answer, but it takes more time than graphing, because when you graph, you use a tool and then it's there. But if you solve it algebraically, yes, you need to actually work. Okay, so in this lesson, we'll think about how we can use substitution to solve a problem, solve a system of linear equations problem. Let's look at example number 1. Solving systems of equations using substitution. So what's the solution for the system of equations here? Okay, if you use substitution, you have the first equation that's equal to y. So instead of using y on the second equation, you're going to rewrite that y using 6x plus 7, because y is equal to 6x plus 7, right? So instead of writing y, you're going to write 6x plus 7. So that you combine those two equations. And then you're going to solve for x, distributive property, and then addition property, substitution property, right? Yes, and then you get x is equal to -4/3. In order to check for your answer, this is the answer. But you can substitute this back into your first equation to see if your y, to figure out your y, right? Because x is just the x coordinate, but your answer, your solution is 1 point. You need both x and y. So substitute this to either of the solution, either of the equation, and you should get the same answer, -1 for y. Okay, so your point of solution is -4/3, -1. Okay, and then you can check your solution by substituting the x and y values into both equations and see if that makes sense. -1 is equal to -1, 4 is equal to 4, so it's true. Let's look at try number 1AB. Use substitution to solve each system of equations. Come back when you are ready. Okay, so you have in part A, you have x is equal to y plus 6. Doesn't have to be y equals to. If you have x equals to y plus 6, then you substitute that into x instead of y. Okay, so you have y plus 6 plus y is equal to 10 instead of x plus y. We have the same variable now. We can solve for the variable. We have y plus y, which is 2y, and then plus 6 is equal to 10. You subtract 6 on both sides. 10 minus 6 is 4. So you have 2y is equal to 4. Divide both sides by 2. 4 divided by 2 is 2. You only have y, you're not done. Substitute your y is equal to 2 back into your first equation. 2 plus 6 is x, and that's 8. So your solution is a comma 2. Okay, you can check your solution by plugging in your y values and x values, right? So when your x is 8, y should be 2. When your x is 8, y should be 2 for a second equation as well. Okay, and they both make sense. Part B. Your y is equal to 2x minus 1. So you're going to substitute this into your y. Okay, so you have 2x plus 3 times 2x minus 1 is equal to negative 7. You have 2x plus 6x minus distributive property 3 is equal to negative 7. Add the like term. 6 plus 2 is 8x. Add 3 on both sides. You get negative 7 plus 3, which is negative 4. And then you have x is equal to negative 4 divided by 8, which is equal to negative 1 over 2. X is negative 1 over 2. And then plug it into your original first equation. 2 times negative 1 over 2 minus 1 should be y, right? So that's equal to negative 1 minus 1, which is negative 2. Okay, so your x is negative 1 over 2, comma, y, negative 2. Ta-da! And you can also plug these points back into your two equations to check your solution. Okay, but your answers are these points. Let's move on to example 2. Compare graphing and substitution methods. Okay, we have two methods so far, graphing and substitution. We're going to compare them in this problem. A vacation resort offers surfing lessons and parasailing. If a person takes a surfing lesson and goes parasailing, she will pay a total of $175. On Friday, the resort collects a total of $3,101 for activities. How much does each activity cost is the problem. Okay, so we have these two equations. X plus y is equal to 175. And 20x plus 16y is equal to 3,101. What do x and y represent? X is the price of a surfing lesson per person. This is a price, okay? Y is the price of parasailing per person. So we're talking about price here, okay? Parasailing plus surfing total, one parasailing, one surfing is 175. And if you have 20 people taking surfing lessons from the graph, okay, and 16 people parasailing, together, total, they have $3,101 that are paid, right? So how much do they really cost? They didn't tell us. We need to figure it out, okay? So what does the first equation represent again? The cost of X of a surfing lesson plus the cost of Y, parasailing lesson, equal to 175. Okay, we just know the total price for that of one surfing and one parasailing. But then we know 20 surfing plus 16 parasailing is total 3,101, which is the second equation. Okay, method 1, you're going to graph the two equations and you have a solution point 75.25, 99.75. Okay, so X represents the surfing, right? So surfing lessons cost $75.25. Parasailing lessons cost $99.75. So this happens to be an exact solution where the decimal were not rounded up. It's exactly 2.5 and 7.5. So they're exact solutions and they're valid. Method 2, you're going to solve the system of equations by substitution, like we just did in the last example. You have two equations, you substitute one by another, but we don't have an equation that says x is equal to something or y is equal to something, right? We need to isolate the variable, one variable. So here we isolated x. You can also isolate y, it doesn't really matter, okay? Your x and y should still be the same. But here we isolated x first. And then we substitute x with 175 minus y into your second equation. Then you solve for y. And then with the number, with the value of y, you plug in into, substitute again the value of y into your first equation. And now solve for x. You substitute it until you get both values, right? And then you can check and make sure that they make sense. And they do. So your x and y's are 75.25 and 99.75. Okay. And you need to remember which one represented which so that at the end you can say, oh, surfing costs 75.25 and parasailing costs 99.75. If you just get the number and you don't know which one is which, it doesn't really help in the situation, right? If you want to go surfing, you want to know how much it costs. All right, let's try number 2. Come back when you're ready. On Saturday, the vacation resort offers a discount on water sports. To take a surfing lesson and go parasailing costs $130. So now we have different costs. Okay, surfing lesson, again, that's going to be X. Parasailing cost is going to be Y. If you have X plus Y, it costs $130. Okay, that day, 20 people took surfing lessons, 25 times X, how much it costs for surfing, and then 30 took parasailing, so 30 times y, and the total is 3,650. So we have two equations again. What's the discounted price of each activity? Let's use substitution. Of course, we can use graphing as well, but let's use substitution so that we get a good practice. We're gonna isolate x or y. We're gonna isolate y because we isolated x in the example. Y is equal to 130 minus x. You're going to substitute that into your second equation. Okay. 25x plus 30, 130 minus x is equal to 3650. Okay. And then you use distributive property. Then you have plus 3900, okay, minus 30x is equal to 3650. Okay, and then 25 minus 30x is negative 5x. Okay, so we subtract 3650 on both sides. And then we add 5x on both sides to get this, okay? And then you have 250 is equal to 5x. So x is equal to $50. We're not done, what's y? Y is equal to 130 minus x, which is 50 now. So 130 minus 50 is 80. So which is which? X is surfing lesson, parasailing is y. So surfing costs $50. Parasailing costs $80 is your final solution. Okay. Let's look at example 3. Systems with infinitely many solutions or no solution. Uh-oh. Now we have some special solutions. What happens when we have a special solution? Let's try to solve for this system of equations algebraically using substitution. Okay, we're going to use substitution to substitute the first equation for y on the second equation. Then we're going to solve for it, and then the x variables disappear. And 6x minus 6x is 0x, so it's gone. And we're left with -2 is equal to -2. Okay, x is gone. Don't panic. You still need the leftover numbers. Does -2 equal to -2? It is true. It is a true statement. It is an identity statement. So it means it has many, many solutions. These two lines are actually the same line. In fact, if you change this to slope-intercept form, you have 2y is equal to 6x plus 2. And then divided by 2, you get y is equal to 3x plus 1. And so that's equal to y equals 3x plus 1. So they're exactly the same equations. You're going to have infinitely many solutions. Okay? What if there are no solutions? Part B. If you do the same thing and then you're left with 4 is equal to -4. Okay, your x is gone, but don't panic. You still need your leftover numbers. Is 4 equal to -4? No, 4 is equal to 4, -4 is equal to -4. So 4 is not -4. It is false. So the system of equation has no solution. Okay. In fact, they're going to be parallel lines. If you change it to slope-intercept form, you get y is equal to 5x plus 4. Okay, they're different equations. They're not exactly the same. So it's not infinitely many solutions, but their y-intercepts are different. Their slopes are the same, which means their parallel lines are never going to meet each other. They're never going to have a single point that they have in common. They're not going to have a solution. Okay. Number 3, let's solve each system of equations. Solve and come back when you are ready for answers. All right. So let's use substitution. We have y is equal to -x plus 5 on the second equation. So we're going to plug that into your first equation. Okay. X plus -x plus 5 is equal to -4. And you have x minus x plus 5 is equal to -4. X is gone. You have 5 is equal to -4. That is not correct. So this is no solution. Okay. Part B. Let's substitute this into your second equation. 2x plus -2x plus 5 is equal to 5. We got 2x minus 2x, so that's gone. We get 5 is equal to 5. Is that true? Yes, that is true. So it has infinitely many solutions. Okay. All right, let's look at the last example, modeling using systems of equations. What are some word problems? What are some more word problems? Nate starts a lawn mowing business. In his business, he has expenses and revenue. Nate's expenses are the cost of the lawnmower and gas, and his revenue is $25 per lawn. At what point will Nate's revenue exceed his expenses? Okay, we got lawnmower, which is $200, gasoline, $2 per lawn. So we're gonna think about how much he spends to do the job and how much he earns, right? To see where the revenue will exceed his expenses, will cover all the expenses, right? So first we're gonna write a system of linear equations to model his expenses and revenue. We're gonna have two equations. Okay, expenses is when you have y as the total of expense when you spend 2 times how many times in moles, right? Per lawn. This is x represents the lawn, right? 2 times x plus 200 because that is the initial expense. It doesn't change. And his revenue, he earns $25 per mowing a lawn. So he's gonna, every time he mows a lawn, he's gonna earn 25. So how many lawns does he have to mow in order to earn more money than what he initially paid for, right? What he initially prepared for. So we're gonna substitute y in one of the equations, or you can set them equal to each other, right? 25x is equal to 2x plus 200. So for x is about 8.7. So since x is the number of lawns Nate mows, it needs to be a whole number, right? So if he mows 8 lawns, is he gonna earn more than his expenses? No, he needs to mow more than that. So after 8.7, the bigger number right after 8.7 is 9, the whole number, right? So he's going to mow 9 lawns in order to go past his expenses. Okay, so 9 lawns is going to be the answer. All right, let's try number 4. Funtime Amusement Park charges $12.5 for admission. So when you go into the amusement park, you pay the ticket price. And then every ride, you also need to pay 75 cents. So River Edge Park charges 18.5 for admission, and then 50 cents per ride. For what number of rides is the cost the same at both parks? So first, what are 2 equations that we could write? Okay, what do we not know? What are variables? The number of rides. Okay, y is gonna be total cost, and x is gonna be number of rides. Okay. So in River Edge Park, Funtime Amusement Park, they're gonna pay $12.5 for admission, and then plus $0.75 per ride, which is X, number of rides. Okay. River Edge Park, you pay $18.5 for admission, and then every time you ride something, you pay $0.5. Okay. Our cost has to be in dollars. If you use cents, you have to use cents for the admission as well. So we have these 2 equations. We're going to set them equal to each other. 12.5 plus 0.75x is equal to 12. Wait, is that 12? No, 18.5 plus 0.5x. Okay, subtract 0.5x on both sides. We get 0.25x is equal to 18 minus 12.5, which is 5. Yes, 5, right? No, 6, I'm sorry. Okay, so then x is equal to 6 divided by 0.25. How many 0.25s go into 6? How many quarters do you have in 6? 24. Okay, so 24 rides. When you ride 24 rides, you pay the same amount for both amusement parks. So your answer would be 24 rides. Okay. All right, let's summarize our lesson. Solve by graphing and by substitution. When you're graphing, you have a point here that intersects both graphs, right? The point of intersection is going to be your solution. By substitution, you can get more exact answers. You're going to substitute one variable to another equation and then solve for one variable, then substitute that value into the other equation and solve for the other variable. And then you have both x and y, and that is going to be your solution. Okay, that was lesson 4-2, solving systems of equations by substitution. Yay! We're going to learn our next lesson in the next video. Thanks for watching. Bye.